Hello and welcome to the second class of CSC 303. Myself, Dr. Devashish Mitra. Today we are going to discuss about uh, the problem solving through computer. Now, before I go ahead, let me just point it out that due to limitation of time, I may move a little bit fast and may not address all queries raised within the class. So, for any query beyond the class, there are multiple channels through which you can reach me. You can obviously email me at my official email ID given, and uh, in order to prevent your mail to be lost within a very large number of mails that I receive every day, it is recommended that you start your subject line should start with CSC 303. Anything, but you just keep CSC 303 at the beginning of your subject line of your mail. And you can reach me through mobile. It is recommended that uh, you should try to call me between 8 p.m. and 9 p.m. every day. And if somehow I fail to pick up your call, just try once more, and alternatively you can send an SMS indicating your name so that I can call you back. And I'll also try to make myself available through Google Meet on every Saturday from 3 p.m. to 4 p.m. with the same link, when many people want to discuss a particular topic or um, for discussion of some advanced materials in each week. Okay, so these are the channels you can avail for reaching me beyond classes. So, as I was mentioning in the very first class of this, introductory class of this subject, that one of the most important skills that a CS professional is supposed to have is problem solving through computer. It may appear to be a little bit vague, but let me just try to elaborate that a bit. And this is the one of the skill that will make you people distinct from your peers doing BTechs or any undergraduate courses in other disciplines. Now, first of all, I mean, when to use computer, how to decide. I have got a problem. When I should seek help from computer to solve that problem. Not all problems can be solved by computer, but most of the real problem can be solved. But we can manually also solve many problems. Actually, computer cannot solve. It do not have any brain, so we need to guide computer to solve our problem. But when and why we should approach or take help from computer to solve our problems? Obviously, there are two specific reasons for which we seek help from computer. One is when we want very fast response, like we can solve the problem manually, but it may take very large time. Whether if I solve the same problem through computer, I may get result very soon. Now, there is another instance that when the problem instance or size is very large. That means it cannot be solved in reasonable time by human being. Like if I ask to add say 1 million, um, find the maximum from a set of 1 million integers, I can obviously find it, but it will take unreasonable amount of time. Whether if I can just program it a bit, use a computer programming, uh, the problem will be solved in a reasonable amount of time, very fast. So these are the instances where we should approach computer. This is very simplistic example, but in reality, this is the basis of taking help of computer to solve our problems. Just like if I type in Google any topic of my interest, it returns billions of results, URLs, within a fraction of a second. So this is the key. This is the advancement we have reached, that through computer we can solve the problem very fast, a large instance of a problem. And it is not magic. I mean, the computer scientists have developed uh, scientific and engineering methods to achieve that, and as a CS professional you should learn that. I mean, this is just a mere example. I mean, there are many examples of solving problem, real life problems, through computer, uh, within very fast response. Now, how to use computer to solve my problem? Obvious answer is writing and executing computer program. And computer program is basically a sequence of instruction in a specific high level language. Like you have already learned how to program in C. So you have to just understand the vocabulary of a high level language, use that compiler of that particular language. You need to know how to write or instruct computer. As I have already mentioned, and you all know, that computer do not have a brain. The method has to be developed by a human being, a programmer, and that instruction, set of instructions. So you need to guide computer how to achieve the task. So that is the thing, what we call program. So it's a sequence of instructions that a computer need to perform. We need to instruct the computer that do this, these are the sequence of step which you follow. So basic computational steps. So we need to do everything. And you might be saying that, sir, okay, you are saying that this problem solving through computer, this skill has to be developed by us. So we have already done that in our first year course. We have already learned how to program, and we have made several programming exercises. So it's over. We have got the skill. But that is not all. I mean, problem solving through computer is in general is a big task. Whatever you have done in your first year course, it was you are just solving some very trivial and simple problems that were presented to you in a very simplistic manner, and you have not derived the solution yourself. The solutions were actually solution approach, the solution recipe were already developed, and you have just learned that, and accordingly you have just learned how to program the solution. So if you look in general method of solving an unknown or real life problem, it contains three major steps. So you have just mastered on only one or last step. Okay, so first step of dealing with any real life problem that may be known or unknown is to modeling the problem as a computational one, because through computer programming we can only try to solve a problem that is a computational one. A computational problem, for simplicity we can consider, is a problem that can be expressed as having some input specification with some input data, and the solution approach will consist of manipulating those data to reach to a output data basically. So the modeling step contains specifying input, what will be the input, what will be the outputs, and what are the constraints, that what I can do and what I cannot do with the input or output data. Okay, so basically these in general needs a lot of computational thinking. I mean, this is the term you may have heard, and basically you need to develop the skill of computational thinking so that you can actually convert or model any problem that may appear uh, from a different domain. It may not look like at a first glance that it is a computational problem, but your job is to model that problem in such a way that it is dragged to your domain, and it is uh, modeled as a computational problem, and solving that problem in your domain may actually indirectly give the result of that original problem. And in doing so, in computer science we mostly use, extensively use the concept of abstraction. Abstraction is nothing but hiding details. Just extracting the key information needed to model a problem, from a real life problem to a computational one. So, in actually, under normal situation in classroom based teaching, I used to spend 2 or 3 more classes to illustrate these steps in great detail, but this time, due to limitation of time constant, I am skipping them. Hopefully, if time permits, after covering the data structures um, assigned to me, I may discuss this type of things a bit beyond the schedule of the class. Let's see. But you will, through in your entire journey of this BTech in computer science, you will got to know that how to use abstraction, how to use your computational thinking skill, or develop your computational thinking skills. That's very important. So, in the most of the problem you have solved in your first year, these steps was automatically done. You have been presented the problem which was uh, actually modeled as a computational one, or which were apparently the trivial problems who appears to be an inherently computational one. Okay. Now, next step is a very important one, that before programming you need to develop the blueprint of your solution. That's what is called algorithm design, that how to solve the problem. Okay. And in doing so, in most of the cases, you need to explore various possibilities. The single problem may be solved with different methods, and there are very important and popular tools and techniques, and very powerful tools and techniques have been developed in the field of computer science over the years. For example, those are called recursion, greedy decomposition, divide and conquer, dynamic programming, and many more. And in your, again, as I have said, that in this course as well as in the upcoming semester, you have analysis, design and analysis of algorithms, and many other courses in your BTech CSC. You will be able to explore these existing solutions or tools and techniques, powerful techniques, and how to adapt them. You may not directly use these to solve any problem that you face. Okay, but you should learn how to use them or adapt them to solve your problem. So this is another objective of studying many subject in your computer science. Okay, so here I will not going to discuss such thing in this particular course, but as I mentioned, if time permits, I will at least illustrate how recursion can be used to find out solution recipes of many different kinds of problem. And also, after you have got many possibilities, you need to choose the best one depending on some criteria. Now, how to choose that one possibility is to implement different possibilities. That means write program for each of these solution recipes, and then check which one is performing best. But it is not recommended, it is not possible. That very complex problem, you have come out with several complex alternatives, you will code it and then you will decide. So there are ways in computer science through which you can judge or analyze your possibilities without implementing them, and you can find out the best option, and then try to implement that particular best option only, leaving others. And in few, in next few lectures covered by me, I will discuss those things, that is called analyzing algorithm without implementing the particular algorithm. Okay, I'll introduce that, how to do that, how to analyze different possible algorithmic solutions of a problem without implementing that, and from that how to choose the best one for implementation. Okay. Now third step, once you have finalized or chosen the best alternative solution recipe, now you have to convert it to a real program, because the solution recipe is a vague one represented as pseudocodes or flowcharts or something, some informal ways. Now actually, in order to get the actual result, you need to convert that particular solution recipe presented in pseudocode or any other intermediate format to a real code written in a specific high level language like C. So for that you need to learn the vocabulary of a specific high level language, what you have done in your first year course. And in doing so, converting a blueprint into a real program, you need to take care about user interface, because the program is going to be used by you are writing the solution, but you will actually provide that solution program uh, for executed by real users. So the interface, how they will provide input, what output they will get, you have to make a user friendly interface, that you have to take care of. And also, you have already modeled the problem as a computational one, which is basically comprising of data and manipulating data itself. Your solution recipe is nothing but how to manipulate that input data to reach to a particular output data. The data structuring or organization of data will become very important, which we will discuss later in great detail. And also you need to consider error handling. So these are the main important components that you need to take care while converting your blueprint into a program. So these particular slides demonstrate a very important thing, but in a very concise and lucid manner. In your entire journey of computer science, as I am mentioning again and again, that these things will get explored by you. It is not that everything can be explored in this single course. Okay, but you must need to have an overall idea that what is meant by problem solving through computer. It is not just writing a program of finding out maximum or minimum, sorting, not like that. It is beyond that. You need to develop a skill to uh, solve any real life problem. As I am saying, that at the first glance may not look like a problem that can be solved by computer. That is very important thing you need to understand. Okay. Now, as I have mentioned, that modeling may be very trivial for problems that are inherently computational. Like if I ask you to find the highest score in JEE Main in 2020, so there will be a hell lot of scores. So many candidates have appeared in JEE Main, but the problem is itself uh, inherently computational. That means if you describe the problem, it will look like that there will be a set of scores given. The scores will be associated with different candidates. Maybe that set may be very large, but this is the thing, and you have to find out the maximum among that set. So it is basically solving this problem will be similar to finding the largest among a given set of real numbers. And though manually it will be very tedious, but since computer can handle a large number of instances, so this problem is very trivial to attack by a computer. Similarly, if you are asked to arrange the students in a class in the descending order of their CGPA, that means it is just equivalent to sorting in descending order. So again, this problem is also can be specified in very easily. There will be a given set of CGPAs obtained by set of students, and you need to just sort them accordingly. So this is very trivial, but sometimes for problems that you may encounter, you may be asked to solve, or you may be approached to take care of that problem, that may not look like a computational problem at first glance. And there lies the challenge, that you need to convert that particular problem, which may appear in a different domain, to use abstraction and your computational thinking power to convert it or model it to a problem of your domain, that is a computational one. For an example, very very vague example, let me give one scenario, that suppose a municipality wants to install the water pipeline in a certain locality for distribution of drinking water. So there will be a central reservoir, and there will be households where it uh, needs to lay the pipeline, so that the pipelines reach each and every household, and from that they can be supplied drinking water. Now it looks like a problem in, it's civil engineering problem, but see that this before the actual installation of this problem, there is a scope of uh, estimation, cost estimation and optimization. How? That's actually, without loss of generality, you may easily assume that installation of this pipe has cost. It's not only the length, the cost of the pipe, but there will be many other stuffs associated with that. But whatever may be, you may hide many detail, that the cost will always be proportional to the length of the pipe to be installed, because it is not just directly related to the length of the pipe or cost of the pipe, but if you consider the manual labor that need to be deployed, will also be proportional to the length of the pipeline. So there may be several topology through which you can just lay the pipeline, but a municipality may approach to you to find out the best topology for which the total length of the pipe that needs to be installed will be minimum, and that will minimize the cost. Understood? Let me elaborate a bit. So suppose the most trivial way of installing the pipeline will be like this. It's a kind of star scenario, that a dedicated pipeline will start from the central reservoir and reach each separately to each and every household. Obviously, uh, it is not needed. This will be very good in the sense that all particular household will get a dedicated pipeline, but the cost, obviously the total length of this pipe will be very much high. Whereas you can have an alternative layout or topology like this, that it's kind of distribution of land, as you have seen, that in this way also pipeline can be laid, that all household can be reached. See the difference? Obviously, without going into very detail, it is quite apparent that total length of the pipe here in this topology will be less than this one. And also this is not fixed. There are many other different topologies that is possible to achieve this. So we have got several options. So how to get the optimal one? How to plan the topology for this pipeline distribution? Okay. Now see, this problem, which was apparently at a first glance appears to be a problem of civil engineering or any other discipline, but this optimization and the abstraction actually helps it to convert this or model this problem as a computational one, that given this particular map, we'll see. I'm not going into the detail of solving or modeling this problem, because in this course, if time permits, I will show that this problem can be modeled as a very very famous, already explored, very popular and famous problem of finding minimum spanning tree in a graph. So if we, when we will discuss graph data structure, we will discuss this problem and modeling this problem and finding the solution. There are elegant ways of solving this problem. So initially this problem may not look like a computational one, but this modeling, the power of abstraction, will help you to model this as a computational one, and model this problem as a computational one, and take help from computer science to solve this problem very elegantly. Okay, that's my point. So the modeling is a very key step in approaching any kind of real life problem. Now, next step, how to develop the algorithmic solution. The given you have already modeled the problem, you have some input data, you have the problem statement using that data, and you know what is the required output data. So this is the problem specification. You will have some input data, you will have some output data, and problems. And this input data may not be statically available at the beginning of the problem. It may come during the execution of the solution also. Fine. And this is a very trivial example I have given, that we need to find out the maximum from a given set of integers. So what will be the input data? A set of integers, and the problem statement will be find the largest, and your desired output will be an integer which is the largest one among the given set of integers. Now what will be your solution recipe or algorithm? So basically your solution recipe will be nothing but a set of instructions that manipulates and processes the input data to reach reach to a state where the output data gets output. Okay, so we can reach to the output data from. So basically your solution recipe comprises of instruction of manipulating this data. And manipulation means you have to access the data, that read the values of the input data you are taking. You may have to update them to get some intermediate result and use them again. And you might have to, since when some data are coming as a stream, then you need to insert that data, and also sometimes you need to remove some of the data. So basically in the whole journey of getting the output data from your input data through your solution recipe or in set of instructions, the organization or structure of data becomes very important, because in this entire solution strategy you have to develop to solve a computational problem, you have to deal with data basically. So these instructions as well as the organization of data, since this instruction will involve in manipulation of those data, because the good organization can give make your solution recipe efficient, because otherwise a poor organization may lead to a complex and time consuming execution of your solution recipe. We'll explore these things in a very very detailed manner in this particular course in future. Okay, so what will be the desirable property of an algorithmic solution? The solution, and this sometimes this is called algorithm, sometimes it is called solution recipe or whatever. Basically this is the heart of your solution. Solution, and once you have finalized that solution, the next step will be the implementation. So we need to put a lot of effort to understand how to develop this solution. This is a key thing, and how to analyze the several alternatives to choose the best one. Okay. Now desirable property of an algorithm solution will be these. One is it must terminate after a finite number of steps. Your algorithms or your solution recipe or the set of instructions you are going to present as your algorithmic solution must terminate after a finite number of steps. Okay, so it may not run for indefinite time. Okay. For see, for different instances, for different run of your solution with different instances, the number of steps may vary, and that needs not to be fixed, like solving finding largest from a set of 100 integers and finding largest from set of 1000 integers may be different, obviously. And even for the same 100 integers, finding largest from 100 integers, there will be different set of inputs of 100 integers, and the number of steps may vary, fine, but it must terminate and give back you the result after a finite number of steps. Understood? So it's not fixed, but it must be finite. And second thing is that the algorithmic solution must be functionally correct. That means it must produce correct answer always. It's not like sometimes it is producing correct result and sometimes it may not produce. There must be guarantee. You need to prove that this algorithm is going to produce the correct result. Okay, after a finite number of steps always for any given instance of the problem. Okay, and third number is the desirable property is efficiency. So the efficiency, what does the efficiency means? Efficiency is basically performance. Now performance, there are two things we will explore. One, obviously the most important is the time, since we want fast result, so faster response. If there are two different possibilities or possible solution recipes for same problem, which one will prefer? That obviously which one will give result in fast. That means faster means obviously it will depend on, we'll see that how many number of fundamental computational steps you need to form. So your solution recipes are basically collection of set of instructions. Now solution recipe A has 10 instructions and solution recipe B for the same problem may have 15 instructions. Okay, and we'll see this instruction means basic instruction. Basic, you need to you should not get confused with the instructions you are writing in a high level language. Actually computer at the lowest level of abstraction performs some basic arithmetic and logical operations like addition, subtraction, multiplication, division, comparison, this stuffs, the fundamental stuffs. Now the performance of a computer will actually dependent on the number of such operations. So we need to very careful about analyzing the algorithm or estimating that number of fundamental number of operations. We'll see when we'll actually discuss analysis of algorithm, that how to estimate the efficiency or time efficiency of different algorithmic solutions approach without implementing that. Okay, and another particular performance measure is of how much memory it is taking, because although for conventional algorithms now this memory limitation is not that much, and now memory has become very cheap. So we'll mostly concentrate on time as the measure of your performance or efficiency of algorithm, but sometimes for very large instances we need to also take care of about memory usage by that algorithm also. So these things we will discuss in great detail in upcoming lectures. Okay, so basically the whole idea of this discussion around the performance will help us to choose the best alternative. Okay, so these two are mandatory requirement to be a algorithmic solution to be a valid one, and this efficiency is a kind of subjective one, which will based on which we will discuss, we will choose the alternatives. If we have two valid alternatives, which one we will choose for implementation or usage, we'll choose based on this performance, and how to do that we will learn in some upcoming lectures. Okay, now the last thing I would like to just highlight today is what is the role of data structure in developing this algorithmic solution or choosing the better alternative. Okay, it is how this performance is related with the data organization. As we have already seen, I mean, this whole journey of the solution approach for a computational problems centered around data manipulation, and for that we need to need to be cautious about the organization or structure of data. Now it may not be clear to you. Let me give you and show you very vague example to very simple oversimplified version of some example to let you understand the role of data structure. Okay, so let us consider this particular problem we are targeting, that you have to write a program that takes the names of a set of person and names of their friends. Okay, and this the friend list will be within that list of the persons you are handling. It is not like if the person A to Z you are considering, so the friendship relation will be lying within the set of A to Z itself. I mean, no person can be, I mean, we will not consider any friend beyond that set. Okay, to make our discussion simple. And you have to write a program so that you can answer the following type of query very easily, that whether person X is friend of person Y. Like in input you have already collected that these are the set of persons you are considering, and also for each and every person who are the friends. And once you have collected that, next your query, you have to address the query that whether person X is a friend of person Y, yes or no, you have to answer. Now how do you approach writing the program? Okay, so suppose you have written the program, the output of your program would look like this, that enter the number of persons. Suppose somebody has entered 6, so next you should ask her to enter the name of person 1. Okay, now once she has entered name of person 1, say Anand, next you have to ask her to enter the names of friends of person 1, like Anjali, Bindu, Boivab, like that. So number 1, 2, 3 in this way, and same thing has to be repeated for 6 different persons. So this should be the user interface. Possible, maybe very simple and poor, but this would be the user interface. Now internally, how do you organize this data? Because you need to collect this data, like the name of 6 person, and for each of these 6 person you need to keep the names of their friends. How to keep that that data you are collecting through this channel? Okay, one possibility is that you keep a person array. Without loss of generality, let us consider person names are as A, B, C, D, E, F only. Okay, these are the name. It's a single character name. For simplicity we are assuming, actually it should be alphabetical string. Okay, for the time being, let us assume the names are only mentioned by single character A, B, C, D, E and F. Okay, now for each of these person A or person 0, person 1, as the index of the array is starting from 0, so there will be other arrays or friend arrays which will contain the names of the friends. And this array, the number of valid entries of this array may be different, like person 0 may have 3 friends, person 1 may have 4 friends. And look that this order may not be important, like BFE, I mean BF or BFE, it doesn't matter. The order of appearance of different person in the friend array may be in arbitrary. Okay, now try to think that how you will address your query. So if I ask you that whether person B is friend of person E, what do you have to do? So first you have to scan through this array to locate person B and locate the index of person B in the person array. This is 1. Okay, and then you have to choose the appropriate array here, because since you are interested in finding the relationship between B and E, So you have to come to the friend array of B, and that for that you need to use this index 1 which you have got by scanning through this array. And so you come to this particular array, and then you have to scan this array again to find out whether this array contains E or not. Okay, so this will be one possible solution approach. And if this person B is changed to some C or D, and if this is changed from E to C or F, same procedure will follow. Okay, so based on this organization, this will be your solution instructions or recipe. Okay, so basically in the worst case, what you have to do, this in order to find this index, you may have to scan this entire array of 6 element or n in general, and then within that array also you need to scan through the last of this array, and this array in the worst case may be as large as this one. So basically here we have to find out n, and then in order to find out this array also, which array you need to go, for that you need to scan through these different friend arrays. That is another, in the worst case, another n comparisons you have to make, and finally this is n. For a single query you need to basically n plus n plus n, 3n number of fundamental operations. Very roughly I am saying, it may not be very complete thing, but very roughly there will be 3n number of fundamental operations you need to perform to address a single query here, if you keep the data in this manner. Now let us consider a different option of organizing this data like this. Okay, say I have a Partition array like this, same thing, and the friend array I am not keeping separate one-dimensional arrays for each of the Partition's friend array. I am keeping a 2D array where I know these indices actually corresponds to a Partition. Like 0 indices is for Partition A, 1 indices is corresponds to Partition B, like this. So I am keeping an n cross n 2D array, and I am filling up this array with either 0 or 1 based on the input I am receiving. That means I am initializing in this array to all elements to be all 0 at the beginning, and then I am just converting each 0 to a 1 if I get that corresponding partitions are friend through my inputs. Like when I find out that Partition A is also a friend of Partition B, so I put a 1 there. When I see the Partition A is also friend of Partition E, I also put a 1 here. Similarly, when I say Partition B is friend of Partition A, so I put a 1 there. So this matrix is a symmetric one, obviously, since this relationship, friendship relationship, is also symmetric. That means when Partition A is friend of B, B is also friend of A. Okay. So if I organize like this, then try to address the same query, am I going to get some benefit in the number of comparisons or number of fundamental operations I need to make? Here I have to do how I need to go. So again I need to scan this array to find out the index of Partition B. Okay, now once I have find out 1, then see, I am interested in whether the Partition B has a friendship relations with Partition E, and what is the basis of keeping this or organizing this data, that if B and E is having friendship among themselves, so corresponding if B is having index 1 and E is having index 4, so this array, 2D array, the 1 4 row 1 and column 4, this particular cell I have to locate. Okay, so I have to scan this partition array twice to get the two indices. That indices corresponds to B and another indices corresponds to E, and accordingly I have to use these two indices to choose the row and column of this particular friend array respectively to locate this particular cell, and I need to check whether that particular cell is having a 0 or 1. Based on that I can decide that whether person E is friend of person B or not. Since there is a 1, I can say that B and E are friend to each other. So now the access of this cell is random, because array has that advantage that any cell can be accessed randomly. You can directly go to that particular location provided you know the indices. Okay, so this part, accessing or checking whether this is a 1 or 0, will be very fast. But in order to do that, I need to find out this array, find out the indexes of this array, row indices and column indices. Okay, and how do I find that? By scanning this array twice. Okay, so obviously it is something better than the earlier one, because it was, in the worst case, it was taking 3 into n number of fundamental operations, because I need to scan this array and then I need to figure out which particular friend array I need to consider by scanning around this, and then again I need to scan this particular friend array once again to find out that whether that particular relationship holds or not. So 3 into n in the worst case, where here by 2n I can get the two indices, and then just using those two indices I can directly reach to the cell and I can get that value. So it will be around 2n. Okay, fine. So it improves the my solution approach a bit. Just the organization of data, different organization of data gives me some advantage. There are more, I mean, depending on the problem, the scenario, we may get different approach, but this is just a way, oversimplified example that how the role of data structure is important in coming up with a more efficient solution recipe. Okay, so that's all I would like to mention today. But before I leave, I mean, so we need to what is the takeaway of this class? So basically, I mean, data structures and algorithms are inseparable. Okay, and in problem solving through computer, there are three important things we need to, important terminology we need to understand, and we need to separately learn. One is algorithm, that is the solution, I mean that is the solution strategy we are employing to solve a particular problem, and computer program is basically the implementation of our algorithm or solution strategy, and the data structure is basically the organization of data in which we are organizing our data in our implementation, so that operations, number of operations, that the fundamental operations, we will elaborate on more what do we mean by fundamental operations. Fundamental operations in reaching to the output from the input is become efficient or less time consuming. Okay, so these are the three important terminologies we need to concentrate, and we need to understand the difference and relationship among them in solving data structure. And as I have mentioned, that the whole journey of this particular course will be to, though data structures and algorithm are inseparable, but we will put more stress on understanding different data structures, or learn different data structure and how to manipulate them, the algorithms that are used to manipulate them to solve many real life problems. The actual uh, algorithmic, I mean developing algorithmic solution and analyzing the algorithms will be dealt in great detail in the course you are supposed to um, undertake in your fourth semester. Okay, that's all for the for today. Any question?